Systems go. Satellite, satellite. -10. Twilight, twilight. I feel the moon pulling me away. Alright, tonight's video is on the moon. A little bit of the history, a little bit of the features, a little bit about the Apollo missions that led us to understand a little bit about the moon. So the moon's old. Some of the Apollo missions actually brought back rocks in which were radiometric dated, and they ranged between 3.8 to about 4.5 billion years old. The leading theory about how the moon became, or that it came to exist, is that a Mars-sized object collided about 4.5 billion years ago. There are 5 major theories. One, the fission theory, and that's which somehow part of the Earth was separated and created the moon. Not a lot to support that theory. The capture theory. It's got quite a bit of support, but it's not entirely supported with everything that we know, especially that's happened in the last 10 years. This is actually what is stated in your book, the capture theory. So that the moon was formed somewhere else and was pulled into the Earth's gravitational field. The condensation theory, that the Earth and the moon condensed when the original solar system began, when the sun first performed nuclear fusion and produced energy, etc. The other one is a colliding planetesimals. A planetesimal is just a small planet in which they collided together, and the moon condensed and gravity pulled everything in together to create the moon there. And the last one is the ejected ring theory, so that the Mars object actually hit the Earth and ejected lots of matter out into space, but the moon kept in most of it, and that's what eventually created the moon. So there's been a lot of studies done, obviously. In the latest 10 to 15 years has kind of ruled out, not entirely, but most likely the first 3 theories are pretty unlikely. The best is probably the last one, in which a large planetesimal Mars-sized body actually hit the Earth and ejected out material from the Earth. And that's what eventually formed the moon. And that's also found in your book. So thankfully, the Apollo missions had many opportunities to land on the moon and do some studies. The Apollo program, was started in 1961, and finally got the first person on the moon in 1969. A lot of people know them: Neil Armstrong, Buzz Aldrin, and those astronauts. While they were there, they actually did a few experiments. So here's a picture of the landing module that actually landed on the moon. There's one satellite that stayed above moon's gravity, and they eventually launched off the moon and connected back up and headed back towards Earth, which looks really far away from the moon. Some of the most things probably everybody knows is that's one small step for man, one giant leap for mankind. Probably seen it on movies, heard it, etc. So while they're on the moon, they actually did several experiments. One of them was a seismic experiment, and it was an extremely accurate machine, a seismograph, that measured vibrations and changes. So sensitive that I would actually measure your footsteps while you're walking on the moon. It only lasted about 5 hours before the battery died. Another one was a solar wind experiment, and they actually did several of these each time they landed on the moon. And that is where they learn about solar wind, what it's composed of, electrons and protons, charged particles, and what happens when the moon goes behind the Earth. The Earth actually kind of blocks a lot of that because it's a magnetic field. And the other one, pretty interesting, is they left a 2-foot box with 100 mirrors, and it is still used today. And what they do is they actually bounce a laser through a telescope off the moon, and they calculate how long it takes and the distance within a few centimeters of how far away it is. And if you watch The Big Bang Theory, they actually reference that mirror on the moon. A lot of people don't realize that there really is still a mirror on the moon. So that's how we know exactly how far away it is. And actually, there were more experiments in the several Apollo missions that followed Apollo 11, but that was the first one that landed on the moon. Some of the features, and this is what I do want you to write down, are the Maria. That is the really dark regions of the moon. So if you think about the face on the moon, the man on the moon, that'd be like his eyes, and kind of outline some of the features. Here you can see it's really dark in here, in this region. It's pretty smooth, and that was actually a basalt, and that is formed by the rapid cooling of molten rocks. Also, chemically, it's a different type of rock than some of the rock found elsewhere. Once we get to rocks and minerals, then you'll learn about the different types of rock. But for now, it's just a different type of rock. It's very dark. Another feature are the highlands. So this region here, down near the bottom part of the moon, there are a lot of highlands. There's a lot of impacts from craters, or that created craters from different material out in space that get pulled in by the moon's gravity and land and leave these craters. This region cooled a lot slower than the Maria. Another feature are impact craters. And I'm going to zoom out a little bit so you can actually see right here is an impact crater. And the moon has some incredibly large impact craters. So when an object does hit the moon or Earth, it throws out material in all the directions. That material is called ejecta because it's ejected from where that object hit. And you can see some of these really long trails that run out this way. Those are called rays. And you can use physics and lots of math and determine the size or the speed of the impact of that object in order to throw that much material that far, hundreds and hundreds of thousands of miles away. Really large impact. So there's just a few of the basic features of the moon. Make sure you got those written down. And the last thing is tides. The moon and the sun affect our tides. So we'll spend a little more class time talking about tides, but here's a short little video that hopefully makes you smile.
Something strange is happening. We've learned that Earth's oceans rise and fall twice each day to create tides. But there's also a tidal bulge, as if the oceans are straining outward. We need you on the case.
I staked out the seaside, read a few science books, and learned that tides are related to the positions of the sun and the moon. The water of Earth's oceans is pulled by the gravity of these two celestial bodies. This gravitational pull creates a tidal bulge, an increase in elevation of the ocean on one side of the Earth. This causes tides. But the sun and the moon aren't the only explanation for the tides. We knew that the moon orbits the Earth, but that's not the whole story. The moon and Earth actually orbit each other.
Why haven't I heard about this till now? Explain.
Imagine two balls, one large and one small, connected by a piece of twine.
Twine is itchy. Better make it string.
String, then. The balls represent the Earth and the moon. Now, imagine them spinning around each other, tied by a string. Because Earth is so much heavier than the moon, its orbit is much smaller. But it is this motion of Earth around the moon that causes the bulge on the side of Earth opposite the moon.
Interesting. So the gravitational pull of the moon and sun, plus the orbit of the Earth and moon around each other, cause Earth's oceans to experience a tidal bulge on opposite sides of the planet at the same time.
Case solved.
Okay, so that kind of explains a little bit about tides. The two major celestial bodies are the sun and the moon. So now I'm going to pull up a blank piece of paper. Okay. Here's the Earth. Here's the moon. It's going to be real ugly, but I'm going to draw in a little bit of water. Now, if the moon didn't exist and the sun didn't exist, besides us not being alive, the water would be even all the way around. It's really ugly, I know. But because the moon has gravity, it actually tends to pull the water toward the moon. And it's not at equal amounts. So gravity has to do with how large the object is and the distance between two objects. So the closer something is, the more gravitational pull it has. That means on the right side of the Earth, the moon pulls pretty hard. Towards the center, not as much. And the far side of the Earth, just a little bit. So those arrows represent the strength of the gravity. And without explaining everything in lots of detail, because the gravitational pull is so much stronger toward the moon, we end up with two bulges. Tidal bulging, like the video said. So one over there and a smaller one over here. So we have a high tide over there and over here. And as the Earth rotates, we end up with a low tide and a low tide. So this would be the North Pole. Don't think that we're looking at it from the side. This would be the top of the Earth. North. Alright, and now I leave you with some more fun.
As I'm headed to the sky way up above me, I feel my body spinning, feeling free enough for me. I am the rumbling sea, so come with me. We only spend 9-5. And you can feel it if you tune into your radio. Look at the sky, look at the moon, look at the way it glows. I ain't no ghost, so don't be afraid to go on this midnight